All right, so 6.5, the title is Solving Linear Inequalities Using Multiplication and Division. So we started solving inequalities last lesson. We only used addition and subtraction. So now we're going to move on to the full-scale solving of inequalities. The reason why multiplication and division come second is because that there's one little catch when we're solving an inequality. When we talk about multiplying and dividing, there's one thing that is very different from the equations when we solve an equation. So much of it is the same, except for when we're multiplying and dividing an inequality, there's one thing that's different, and I want to talk to you about that right away. Okay? So let's walk through these examples. It says this: consider the inequality. All right, this inequality, -3 is less than +6. Okay? Is this true? Question, is this true? Well, you would think about a couple things, right? If you had an amount of something and you had 6 of something, and you actually had less than 0 of something, like -3, 6 would be much greater. If you think about a number line, -3 is to the left of -6, so that means that anything to the right is greater than. So 6 is greater than -3, thus -3 is less than 6. So this is true. It's true always. Okay. Let's just check what happens if we, in this inequality, multiply each side by 3. Okay, so we are testing out what happens to an inequality when we multiply. So if we take -3 and we multiply that by 3, that quantity becomes -9. All right? Now, on a number line, we've probably never done multiplication on a number line before, but think about the size or the distance from 0 to -3. If that distance all of a sudden tripled, we would get to -9 over here. You see that? So that's what happens when you multiply. The distance from 0 kind of gets doubled or tripled or whatever you're multiplying by. Now 6, so this way, this distance here gets multiplied by 3 as well. And guess what? It keeps going on this way. And so you end up with -9 compared to 18. I like it. I like it a lot. Is this still true? What's the answer to this question? -9 and 18. Is that less than 18?
Yes.
Yes. Okay, so in here you say still true. Okay, still true. That's what you want to put in that little blank there. Okay, so multiplication seems to go pretty well here with this. Let's talk about division. All right, so on this side, the second one is division. So let's divide each side by 3. So if we have -3 divided by 3, that gets us a -1. Now on the number line, how might that look? And you can't do everything on a number line, but some of this stuff you can. And so let's just test this out on a number line. Oh, wow. Something's happening. It's not letting me zoom in. Give me one sec. Oh. What's happening here? Okay. So divide each side by 3. So if I have -3 right here, and I divide -3 by 3, I'm actually splitting it into 3 compartments, and the division of 3 would be to here, -1. You see that? -3 divided by 3 is -1. 6 divided by 3, 1, 2, 3, we get 2. So we have -1 compared to 2. Is -1 less than 2? Yes, that is still true. Okay, still true. So far, multiplying and dividing inequalities, whether there's a variable on one side or not, when you multiply the same side of the inequality by the same thing, it appears that the equality still holds true. All right? Now, the notes say this, okay? When each side of an inequality is multiplied or divided by the same positive number, and I'm going to talk about what happens with a negative number soon, but when you multiply or divide by the same positive number, the resulting inequality is still true. Okay? Multiply or divide, the inequality stays true. This means that we can still eliminate fractions. Remember how we did with equations? We had denominators and we multiplied both sides of an inequality, or of an equation I should say, to get rid of the denominators. We can still do that in inequalities. Okay? And we can also divide things by 3 as well. If we have a 3x and you want to get x all by itself, you can still divide by 3 with inequalities. That's totally fine. However, there is a catch. And as I mentioned at the beginning, there's one thing that's different, only one, that's different than solving equations. So let's explore this. Multiply each side by -3. -3, okay. I actually have never really fully explored this on a number line, but I'm going to do that with you today. So -3, okay, and +6. So I'm going to show those on the number line. If I multiply by a -3, okay, let's think about that. If I multiply -3 by -3, a negative times a negative gives me a positive. On a number line, it is the same as multiplying, like tripling the value from 0. That is true. But then the negative sign, you know what that does? It totally flips it around to be opposite. So it becomes +9, as you see here, right? So what happens with the 6? Well, if I multiply by -3, I am indeed tripling the value, or the distance from 0, but +18 multiplied by a negative, that flips all the way around here and goes way over here to -18. So guess what? Now we're comparing -18 and +9. You see that? So this -3 becomes +9, this 6 becomes -18. So what does that mean? If we examine this inequality, is 9 still less than -18? No, 9 is greater than. So this is not true. Okay, it's not true. Similarly, and I won't show this on the number line, but it's the same thing. If you divide both sides by a negative value such as -3, divide by -3. -3 divided by -3 is now +1. And 6 divided by -3 is -2. So is +1 smaller than -2? No, not true. Okay, so here we have an inconsistency. Here we have a problem. Our procedure leads us to an incorrect answer, so we have to adjust the procedure. And you know what happens? When we, at the very end, when we flip a negative all the way around to another side to a positive and vice versa, when we flip that, we're taking that whole number line, okay? We're basically taking the whole number line and we're doing this, flipping it over, boom, okay? It's like going back in time or something. So we take the number line, here's your positive end. Oh, no, sorry, we're multiplying it by a negative. The whole line switches, okay? Now, if you think about this, there's one small little catch here, and this is all we have to do. If we reverse the inequality sign, notice that these both become true. You see that? We leave the numbers where they are, but we flip the sign around. Just like we flipped the number line around by multiplying or dividing by negative, we also have to flip the inequality sign around, and then you're good. So, what can be done to make this true? Very, very important. We must reverse the inequality sign when multiplying or dividing both sides by a negative number. All right, super, super important, and it's super simple. You just have to remember this. In an equation, okay, if you have an equation, an equal sign, think about it. An equation, if you flip an equal sign over, what happens? Haha, still equal. Okay, not a big deal. This doesn't apply to equal signs. But if you flip a less than sign over, okay, you get a greater than sign. So we have to remember to do that. To solve an inequality, we use the same strategy for solving an equation. However, when we multiply or divide by a negative number, we must reverse or flip the inequality sign. So we must flip or reverse the inequality sign. And if you remember that, then you'll have no problems at all, and everything will make sense. And hopefully that makes sense. Why that is because we just take that number line and we flip it around, we multiply by a negative, so the sign has to go with it. All right, let's get some practice here. There's some practice. I'm going to show you this. And I will pause right now and mention just one thing, okay? I marked your quizzes from the first half of this chapter. And many of you are not doing what I'm teaching you to do. Just got to be honest with you. You're not doing it. You know why? Because I'm giving you very simple equations to solve, and you're just using trial and error. You're not showing your steps to solving properly, okay? I wouldn't say the majority of you, but certainly I'm marking those quizzes. I ask you, 2x equals 10. and you just give me, you just say 2 times 5 equals 10, done. And you may think that that's really wise of you because it's so easy. But what I want you to do is I want you to follow the inverse operations steps, and you're not doing that. So again, I am going to show you exactly what you need to do, because the easy equations and the easy inequalities are going to get much tougher, and you're not going to be able to just trial and error in your mind, okay? So you got to trust me on this. And some of you are showing these steps, even though I know it's an easy question. But you will find in math, and this is what I do all the time, all the way up to AP Calculus, when I'm introducing something new, it's an easy question for you to follow the easy steps with. It's easy, and you could probably easily do it a different way, but that doesn't mean that it's okay to do it a different way, the easy way. You have to work on the steps I'm trying to teach you, because those steps will help you with more difficult questions. That make sense? So I look at this and I could probably figure this out just in my head, but I'm gonna go through the steps. So watch what I'm gonna do. I need to get S all by itself in this inequality, and so it's being multiplied by -5, and so I'm going to divide both sides by -5. Divide both sides by -5. Okay? So please show me that. Also show me that you are eliminating this factor of -5 on both sides. Put a little stroke through it. Okay? I'm trying to be very, very clear with you here. So what happens is I have S all by itself on this side, and I'm going to flip over to the other side just real quick. 25 divided by -5 is -5. But I asked myself, it's an inequality, and did I divide by a negative number here? Did I divide both sides by a negative number? The answer is yes, I did. So what's the new rule that we just learned? I have to do what? I have to flip my inequality sign. So a less than or equal to sign becomes a greater than or equal to sign. I don't flip all of the numbers and everything and flip the sign, because then you're not changing anything. But what you do is you keep all the numbers on the left that you have, all the numbers on the right, but then you just flip that sign over and you're done. Now let's check this, okay? Let's graph the solution. So the solution is, I'm going to make a little number line here, and S is greater than -5. So there's 0, there's -5, greater than or equal to, so it's a solid dot on -5, and it's to the right. Does that look right? Does it look okay to you? So what you could do to check this solution is choose a number that is greater than -5, that falls on the number line where this arrow is. I could choose 0, that's easy, or I could choose 1, whatever. So I'm going to choose 0, and I'm going to check. -5 times 0 is less than or equal to 25. Well, that simplifies to 0 is less than or equal to 25. Is this true? 0 is smaller than 25, correct? So that's true. So I have drawn my number line and I've checked. This is my solution. How do you feel about that? Good? Excellent. 5 out of 5? 1 out of 5? Any questions about that? Sometimes in math, so if you're wondering, listen, I still don't understand why we flip the sign. It just seems very random and arbitrary that we just flip the sign. Yeah, I know a lot of things in math seem that way, but again, with repeated observation, the same thing happens over and over again. Mathematicians and our minds recognize patterns, and if it happens over and over enough, there's a pattern there, and so we can make that a rule. And sometimes we don't fully understand why the rule applies. Sometimes we don't. I tried to give you the whole number line example. Maybe that helps. But sometimes in math, there's patterns that happen every time, and so we just make that a rule. And sometimes we don't fully understand until later. So if you don't really fully understand why are we just arbitrarily flipping the sign, you kind of got to realize that, hey, this is the pattern for every example that we can do here, and that is what works. Okay, so don't be too concerned if you're not fully understanding why we do it. We'll just practice doing it, and maybe that understanding will come later. All right, so this one, again, I want to get A all by itself. Okay, so I want to divide by 7, both sides. This is a positive 7. So I'm going to divide by a positive 7. I see that the 7s will divide out over here on this side, so I am left with A on this side. On the other side, I have -3. Now, because this is -3, should I flip the sign? Okay, I see some heads shaking right away. I'm not able to trick you, am I? It's not the fact that this is a negative. Oh, there's a negative. Oh, it's a negative. I got to flip the sign. No, no, no. Only if you divide by the negative. So I did not divide by a negative number. So guess what? This sign stays exactly the way it started. All right? So let's just see if this is going to hold true. I'll just identify this original. So a is less than -3, so number line quick, 0, -3. Open circle, because there's no equal sign, and then I draw an arrow to the left because we're talking about less than. All right, so I'm going to try something like -5 falls in this region. So I'm going to test -5. Okay, here's my check over here. My check. So 7 times -5 should be less than -21. That gives me a -35 over here is less than -21. Is that true? Yep, 35 is way over here on the number line. 21 is, -21 is right here. So this is less than -21. Absolutely true. Good? Easy peasy? Lemon squeezy? Okay. All right. Okay, so I tell you what, I'm going to do this one with you, then I'm going to get you to do some on your own. So this is the last sort of example I want to do with you before I set you free, just for a few minutes. But I have x divided by -4. So if I want to get x all by itself, do I add, subtract, multiply, or divide to get x by itself here? What's the inverse operation of what you see? Multiply. Very good. Okay, good. So I'm going to multiply both sides by -4. Everything by -4. Why negative? Because that's the value that's in the denominator, so I'll multiply by negative. The -4's cancel out. I'm left with x over here, and I've got -4 times -3. That's a positive 12. And the question is, do I flip the sign or not? What do you think? Yeah. Yes, because I multiplied by a -4. So I flip this sign to be opposite. Okay. Let's check that. Again, number line, here's 12, here's 0 over here. X is less than 12, open circle, arrow to the left. So I'm going to check 0, because that's obvious, 0. So 0 divided by -4 is greater than -3. Well, that's 0. Is 0 greater than -3? Well, 0 is to the right of -3, so that is true. So this is my solution. Okay, I'm going just a little bit faster with everything now here because hopefully you're catching on to this, okay? Any questions though? Please put up your hand if you have any question at all. You won't interrupt the flow here at all. If you have a question, please let me know. Might be just a quick answer. We're good? Okay, so I'm going to let you do D by yourself, but remember, all of the operations that we would do to solve an equation is exactly the same, except if we have to multiply or divide by a negative. So if you remember how you did equations, you have to get x all by itself. There's 2 steps you have to do here. I'll get you started. You have 2 decisions to make. You have to divide by 3 or add 12. So which one are you going to do first? Add 12. Thank you. Very good. So let's add 12 to both sides, and I'll get you to finish up now. Okay? That's your hint. Add 12 to both sides. That's your first step. Now you finish up the inequality. I'll show you the answer in a minute. Okay, so everybody finish up D on your own right now. All right, so you can check your work. Let me walk you through it real quick. So, of course, we added 12 first to get 3x is less than 30, 18 plus 12. Then I divided by a positive 3. So that's great. That's x. And 10 over here, and because it was a positive, I did not flip the sign. So x is less than 10. I drew that on the graph. There's 10. I'll draw an arrow to the left with an open circle, and I checked. I checked 0 here, and 3 times 0 minus 12 is less than 18. That is -12 is less than 18. That is absolutely correct. All right? Good? Okay. All right, I'm going to leave you to do E on your own. Let's do this one, example 2. This has decimals in it, so it looks really complicated, right? Looks really complicated. Well, if you want to use your calculator, you can for this, but all the rules stay the same, okay? So it's just the numbers that look a little bit different. All the rules stay the same. So I see an A term here. I also see an A term over here, okay? Well, we should get those together. So it doesn't matter which side you move things to. A lot of times you guys move the variables to the left side always, which is great. So let's try that. I'm going to subtract 1.8a from both sides. Minus 1.8a. So on the left, I have negative 4.4, looks like. Negative 4.4. A. Plus 14.6 is greater than what I have left over here is negative 5.2. All right. So now I'm going to, again, continue to get my single A here now, all alone. So I'm going to subtract 14.6. All right. And I've got negative 4.4 on this side, 4.4a, greater than, this is negative 19.8. So with these negatives, I don't know if it feels more complicated to you, but just focus on each step, focus on your rules, have your calculator beside you if you need to. Don't be too excited here, but we're going to now divide by negative 4.4. Oop. I divided by a negative, so that means I have to remember something. This is going to be a all by itself, because the negative 4.4 divided by negative 4.4 is just 1. And because I divided by a negative, flip that sign around. And negative 19.8 divided by negative 4.4 is going to be positive 4.5. So I reverse the sign. And of course you could check that 0 would fall in this, so you could check with a 0. That would make 0 plus 14.6 is greater than negative 5.2 plus 0, because these a's will be 0. And yes, 14.6 is greater than negative 5.2, so that seems to check out. There's your answer.
Can you show that answer for E really quick?
No, I can't, because you're supposed to do E on your own.
I didn't know.
Yeah, no, I'm not showing you right now. We're moving on. I'll maybe come back to it a bit. Maybe, yeah. Okay, any questions about that one? All right. Okay, let's move on to the last stage of the lesson here. Let's do a word problem. Again, the word problems are, this one's going to include an inequality, which you will see. Hopefully that'll make lots of sense for you. So this one says, example 3, a super slide charges $1.25 to rent a mat and $0.75 per ride. So a sloop, I guess a mat is where you jump on the mat and you go down this big slide, right? I guess that's what they're talking about. So it costs you $1.25 to rent a mat, and then it's 75 cents per ride. Okay? So Jason has $10.25. So what's the maximum number of rides that he can go on? Now think about this. How many rides can he go on? There's not one answer, right? Because he could go on 0 rides. He could say, I'm taking my $10.25 and I'm going home. But if he wants to ride, he could probably do 1 pretty safely. He could probably do 2, and you might be doing some math in your head. Well, I got $1.25 plus 75, that's 1 ride. $1.25 plus 2 times 75, that's 2 rides. And you can kind of like work this through a little bit in your head. But there's a way to find out the answer, exactly how many rides that he could go on, up to a maximum of how many rides. So choose a variable and write an inequality. So we're going to choose a variable, and we're going to solve for that variable to find out exactly what Jason can do here. So I'm going to say R. R is number of rides. Okay? R is number of rides that Jason can go on. And obviously, there will be a maximum number of rides because he's going to run out of money eventually. So how can we use math to help us solve this problem? So I'm going to write the inequality right here. It's going to be the cost, $1.25, that's $1.25, plus 75 cents, that's $0.75 per ride, so times R. Okay, that's going to be the cost of the number of rides, however number of rides he chooses. And I'm going to tell math here, I'm going to say, I need to find out what R is when the money that he spends, this is all the money he spends, when that is less than or equal to what? What am I going to put on the right side? Boom, $10.25. That's right. Let's think about this one more time. So this is what the cost is, right? This is the cost, and this is how much money he has. What was his name here? Jason. This is how much money Jason has. So if I find out what R is that satisfies the inequality, that will give me the number of rides that he can do, which would be, we said he could do 0. He could just take his money and go home. And it could be 0 or maybe 1, maybe 2, maybe 3. Let's see how far it goes. So let's figure it out. All right. So I do everything, follow the rules. I'm going to subtract 125 from both sides, minus 125. And I'll just forego the symbols for now, the unit symbols for now. Okay. And these are gone. I'm left with 0.75. R is less than or equal to, what's that? $8? $9? That would be $9, I suppose, right? And finally, I'm going to divide by 0.75 to get rid of the multiplication on R here on both sides. Now, was this a negative that I divided by? Nope, no negative sign. So am I going to leave this sign? Am I going to flip it or leave it? Leave it alone. Leave it alone. Awesome. So I'm going to be left with R is less than or equal to, if you do that in your calculator, you should get, I think, 12 there. That's 12. Ah! So now what does R less than or equal to 12 mean in this situation? He can go up to 12 rides. He can go on 12 rides and have enough money to do that. So he can go on 0 rides. He can go on 1, 2, 3, 4, all the way up 10, 11. He can even go on 12. He can ride 12 times with the money he has. Now, can he ride 13 times with the money he has? No, because the number of rides has to be less than or equal to 12. So you could probably do, and you know what, to be honest with you, if you're at the Super Slide on Saturday, you have 10.25 in your pocket, you're going to be like, I wonder how many times, I could probably go 3 or 4 times. Maybe I could go 5 times. Let me see. I don't know. I'll just kind of like guess. Okay, I don't know. But, okay, if you want to know exactly, you could write an inequality, and I'm sure at the Super Slides on Saturday, you're going to want to carry a pencil, a piece of paper, maybe your calculator in a pocket, so you can whip the calculator out and just quickly figure out how many rides you could go on, right? And just tell all your friends real quick the answer, right? I'm joking. You're wondering if I'm joking. I am joking, but you could. If I see one of you at the Super Slides on Saturday with your calculator and pencil and paper, I will just, the joy that will fill my heart, I'm telling you, will just be immense. And would you have a bonus? Maybe extra credit, maybe for doing math on the weekend when you're out with your friends. Yeah, that's extra credit right there. If I see that, oh yeah, definitely. All right, so here's 12 rides. Now, let's talk about this for a second, because this is one more thing that you need to understand for this section. There's 2 major things I need to talk to you about, and this I haven't talked to you about yet. Okay, so R is less than or equal to 12. Normally, when we graph this, we would do a solid dot, and then, careful, we would do an arrow, which would mean that every conceivable number less than 12 would be a solution to this problem. But I see some of you shaking your head now. And I mentioned it earlier. If I have money, if I have $10.25 and I go up to the guy and say, listen, according to the inequality that I worked out with my friends back there, if I choose to go on -5 rides, you owe me $6. So I am going on -5 rides right now, so pony up the dough. If you said that, they would look at you like you're crazy. It's like, what, did you invent a time machine or something and think you can come back here and try and fool me? No, you can't. So guess what? You can't go on negative rides. You can't just go up to somebody and say, hey, have you been here before? Yes, -5 times. What does that mean? No, it's 0 times or it's more than that. So we can't go past 0. Now, here's another question for you. In the context of this question, can you go on 1.6752 rides? If you listen, I need you to stop this ride. I'm going to stop right here down the slide, and then I'm going to end. No, it's 1 ride, or it's 2, or it's 3. So guess what? The decimal values don't make sense. So in this case, you're going to have to list 3, 4, 5, 6, 7, 8, 9, 10, 11. You're going to have to list them all. And you're going to have to put, I was going to do this real quick. You're going to have to put solid dots on each whole number, because you can only go on a whole number of rides. So this is a bit of a a difference from what we've been doing before. You cannot use the arrow. And do I include 0 on this one? Do I include 0 on this one? Yeah, I do. I could go on 0 rides. That's not negative. I could go on 0 rides. Okay. So that's how the graph for this one looks. Do you understand? Understand that? Make sense? I hope so. I hope so. Okay. Any questions about super slide example 3? Nailing it? Awesome. Okay, example 4. Write an equation or inequality, we're giving you a choice here, for each statement and solve. And graph all the inequalities. So you have to choose equation or inequality, and then let's write one. So let's see what the wording says here and see what we can figure out. So it says triple a number, then decreased by 1 is less than 11. So is this going to be an equation or an inequality first? Let me ask you that. Okay, it says less than, is less than. Is that an equation, equal sign, or is that less than, like this? Which one is it? This one. So it's an inequality. Okay, inequality. So let's think through this. Triple a number. Now, we don't know what the number is. That would be like it's unknown. So that would be n, okay? N is a number, and I'm going to triple it. So that's like multiplying by 3. So triple a number is 3n. Okay with that? Then this value, this quantity, 3n, is decreased by 1. So how would I express decreased by? Subtract. Very good. Minus 1 is less than the number 11. Wow, this is so easy. Less than sign 11. Okay? Does everyone see how that word sentence there translates to that inequality? Want to see that? Okay? All right. That's excellent. So now let's solve. Oh, this is easy. This is like baby stuff now. I'm going to plus 1 to both sides. I'm going to realize this is just 3n because those are gone. Less than 12. Now what I'm going to do is I'm going to divide by 3 to get n over here. And I divided by a positive, so I do not flip the sign. 12 divided by 3 is 4. Awesome. Now if I wanted to check that, I pick any number less than 4, plug it into the inequality, and the inequality should still be true. So I'm going to do that real quick over here, do a check, and I'm going to pick a number like 2. What's 3 times 2 minus 1? And is that less than 11? That's 6 minus 1. That's 5. Is 5 less than 11? It absolutely is, so I'm confident this is my solution. All right, I'm going to take that phone call. You guys do B. Okay, go ahead and do B. Give this a go. B, a number multiplied by 4. I'm going to go 4, and that could be any number. So I'm going to, any variable, I'm just going to put x there. So a number multiplied by 4 is then decreased by 5. Minus 5 is 1. So that is equals 1. It's frozen? Oh, sorry, increased. Did I say decreased or did I say increased? Oh, I'm sorry. Is increased by 5. Thank you, that's a plus. And so a number multiplied by 4 is then increased by 5 is 1. Okay, so that's an equation. So let's solve that. 4x equals, I'm going to subtract 5 from both sides. So that's going to be negative 4 divided by 4. X equals negative 1. You don't have to worry about flipping any signs with an equation. X equals negative 1. So if I put negative 1 in there for my check, that equation should be absolutely true. Let's just see. Negative 4 plus 5, does that equal 1? Yeah, sure does. There you go. Okay. C. You can invite at most 5 friends to your house Saturday evening. At most. You can invite some friends over, but you can't have more than 5. So that means you can have what?
5 or less.
5 or less. You guys understand that? Awesome. So you can invite at most 5 friends to your house Saturday evening. So let's say F is friends. We already mentioned that this is an inequality. So the number of friends that you can have is going to be what? Someone finish that statement for me. Is what? What would you say?
No, not equals. Like
Less than or equal to 5.
Less than or equal to 5. That's right. Because 5 is the max, but you can have anything less than that. Now, you can't have less than 0 friends. Okay, so you got to be careful with that. We should maybe, if we're graphing this, right, you have to, on the number line, which does have the arrows, you have to start at 0. You have to go to 5. So 1, 2, 3, 4, 5. You put solid dots on each of those numbers. Inviting enemies is not like having negative friends. I don't know. Yeah. I don't have as many friends, but I got a lot of enemies. Okay, so you have negative friends. I get it. Oh. You got to work on that. Oh boy, they're getting tough. They're getting tough. Okay, you do D and E. You do D and E together, please. And then once I'm satisfied that you know what you're doing, I'll give you your assignment. How about that? Go ahead, do D and E on your own, and then I'll compare your answers with my answers, and we'll see who's right.
Do you have to draw a number line?
Yeah, just a note on E there. It should be 7% of a number is 56.7. Okay, guys, let's take a look at the answers for D. I think this is what I. Oh, wait a minute. 5 minus 3. Oh, I have to check something here. 3. So, in your notes, you might have a comma here after 3, which shouldn't be there. But 5 subtract 3 times a number should be 5 minus 3n is equal to 3.5 times the same number, that's 3.5n, minus 8. So here I get n equals 2. Anyone else get n equals 2 there for D? Okay, very good. Any questions about that? Finally, E, 7% of a number is 56.7. 7% is represented by 7 out of 100 times n. If you wrote 0.07n equals 56.7, that's totally fine too. So multiply by 100, then divide by 7, you should get n equals 810. So 7% of 810 is 56.7. All right. Any questions about those last two? All right. I will give you your 6.5 assignment, and you will have, let's see, tomorrow is Wednesday. You will have time tomorrow to work on this 6.5 assignment. You should have, in the time given here now, you should probably have 3 and 4 done by tomorrow to work on the rest tomorrow, but you should get started on this. So 3, 4, 7 to 13, 15, and 16. This is page 304, 6.5, page 304. All right. Okay, so that's 6.5. The big thing here is if you multiply or divide by a negative number, you have to flip the inequality. That's the huge thing you have to remember. The other thing is if you have a word problem where decimals don't really make sense in the question, you might have to fill in dots for each whole number, for example. So those are the two things that we talked about today. And everything else is the same as solving equations. So you can go ahead and get started on that assignment.